Hello and welcome to my second episode on digital circuiting, and today we're going to be going over the symbols for the gates, different logic gates, their truth table, and some of their equation, because we'll say Boolean logic, which is the logic for another episode, like written out equations. But anyway, we'll go straight into it. So first we have a inverter, and this is the schematic symbol for it. So if you see it on a schematic drawing, which I'll show you later with later projects like the adder that we're gonna do. But when you see this, that's an inverter, and that means that whenever it's gonna invert whatever the signal is. So if it takes in a 0, it's gonna output a 1. And if it takes in a 1, it's going to output a 0. And it's really simple. It just makes it the opposite of whatever comes in. So it just flips it again, 0 to 1, 1 to 0. And its symbol is denoted by your output, which in this case is a Y with a line over it. And we'll get into that more later. Our next gate is an AND gate. And this is pretty much saying, well, let's go to the symbol. The symbol, if you see in a schematic, that's what it's going to look like. It's not going to have this AND symbol in the middle, but it is going to have this this straight line and then this rounded curve, 2 inputs and an output, and it might say AND over it. But anyway, so its truth table is this. So it's an AND gate. So when A and B are high, or have a 1 coming to them, then it's going to output an I, and that's a high, and that's the only time where it will output a high. If only one of them is on, or none of them are on, it's not going to output an I. It's waiting for both of them to be on. Our next gate is an OR gate. You're not going to see this symbol in the middle, but the rest of it will be the same. It might say OR over it, and it's going to have 2 inputs and an output. And we'll go into later, because you can have one with like 3, 4, or infinite amounts of inputs, and we'll go into that later. But anyway, this is going to be when one or the first one is on, or they're both on. So it's one or the other, and also if they're both on. So the only time when this gate is going to be off is when both A or B do not have any high signals going to them. And a 1 is current coming, or not current, it's voltage, and a 0 is no voltage. Anyway, so this is the truth table. If A is low and B is high, then it's a 1. If A is high and B is low, then it's also a 1. And if they're both high, then it's a 1. And our last gate, which is not part of AOI, which is AND or an inverter, but you do need it for the adder, is the exclusive OR. So this is the same thing as the OR gate, but it actually is an OR. So it's only one or the other. It's not both. So again, this symbol will be there in any schematic drawings, but the symbol in the middle will not be there. So it's one or the other. So it's either A is on or B is on, and if one of those isn't on, then it's not going to be a high. But if both of them are on, then it's a low, because it's exclusive OR. It's waiting for exclusively when it's one or the other. And then it's A, B. When both of them are low, it's going to be low, except for the inverter. So these are the 4 gates that we're going to predominantly be using for the first couple episodes, and then we'll move into some different gates that you can use. And we'll also be going, when we get into more complex circuits, we're going to still be looking at it from the gate standpoint. But anyway, thanks for watching, and next episode we'll be simulating these gates in Minecraft.